Hey there. Ready to have your mind stretched by some elementary school math?
We're diving deep into area and perimeter, and you might think, okay, squares, rectangles, I got this. But trust me, things are about to get interesting.
Interesting how.
Well, we've got these excerpts from a children's math book, and let me tell you, they don't shy away from the surprising depth of these concepts.
Okay, I'm intrigued. Lay it on me.
So they start with this scenario, right? Two kids, Parth and Janini, they both buy these delicious-looking dried mango slices. You know those Amambin Pop had, right?
Oh yeah, those are good. So what's the math problem? Who can eat them faster?
Uh-huh, not quite.
Hmm?
The shapes are all irregular, right? And each kid is convinced they got the bigger piece. Classic kid dilemma.
Ah, so we need a way to measure who's got the bragging rights. I'm with you now.
Exactly. It's not as simple as just looking at it, right? So the textbook introduces this brilliant idea using small squares, kind of like tiles, to cover each mango slice.
Oh, I like where this is going. It's like a visual way to measure. Yeah,
You got it. You can immediately see which slice needs more tiles, more squares, and boom, there's your answer. Larger area.
such a powerful visual, right?
Yeah.
It gets at that core concept of area.
Yeah.
Is the amount of space something takes up. Doesn't matter how complicated the shape.
It's like you're laying down a grid to measure the world one tiny square at a time.
Precisely. And this textbook, it doesn't stop at squares. Oh no, they've got rectangular stamps.
Stamps, like for mailing letters.
Exactly. They've got this activity called Cover with Stamps, and it just drives the concept home.
Okay, so how do stamps help us understand area?
Because now you're thinking about different units of measurement. Square centimeters, square inches, you name it. And you see how area calculations, they just work, regardless of the shape.
So it's like the principle's the same whether you're talking about a mango slice or a postage stamp.
Exactly. And that, my friend, is a fundamental concept that applies to so much more than just basic shape.
Okay, I'm hooked. So walk me through this. How do they connect those stamps to something, say, you'd encounter in everyday life?
Well, they use examples like figuring out how many tiles you'd need to cover a kitchen floor.
Okay, that makes sense. Practical stuff.
Right. Or how much fencing you'd need to enclose a garden. And boom, there's your perimeter. Right.
So that's where perimeter comes in. But hold on. You can't just measure the outside of something and know how much space it covers, can you?
Exactly. And that's a key distinction the book makes, right?
Yeah.
Two shapes can have the same perimeter, same amount of fencing, but totally different areas inside.
Which means one garden could hold a lot more tomatoes than the other. I like where this is going. How does the textbook get at that?
Okay, so they have this activity. My belt is longest. It's pretty clever, actually. Imagine taking, like, a sheet of paper and cutting it into a really long strip.
Okay, so like a paper chain, kinda. We used to make those as kids.
Yeah, exactly. Now, you haven't changed the area of the paper, right? It's still the same amount.
But you've stretched it out.
You got it. You've drastically increased the perimeter, though.
Wow, that's a really cool way to visualize it. Same amount of stuff, but wildly different boundaries. Makes you think about the possibilities. Okay, but this textbook doesn't just stick to shapes on paper, does it?
Oh, no. They take these concepts, area, perimeter, into the real world. Even population density, they talk about that.
Population density. In a children's math book, how does that even work?
Well, it uses this example of two Indian states. West Bengal, which is super densely populated.
Lots of people packed in there.
Exactly. And then Arunachal Pradesh, which has a much sparser population.
So even if those states were, like, roughly the same size...
You'd have way more people per square kilometer in West Bengal.
So that's population density in action.
Exactly. And understanding that, it's crucial for all sorts of things, right? Urban planning, resource allocation.
It's amazing how this stuff connects, but it doesn't stop there, does it? What other real-world applications do they get into?
Well, they also look at land division, which gets surprisingly tricky.
Oh, yeah, like when people inherit land. That can get messy.
Right. And they have this scenario with a farmer, Nazrina. She wants to divide her land equally among her children.
Sounds simple enough. Just break out the ruler.
Except the land isn't a perfect rectangle naturally. And to make it more interesting,
Oh, there's always a twist.
each child needs to have a tree on their plot.
Okay, so now it's not just about the area, it's about the resources, too.
You got it. It highlights this very real challenge, right? Dividing irregularly shaped areas fairly. It comes up all the time. Inheritance disputes, property surveys, you name it.
Practical math. Okay, but it gets even more intriguing. There's that story about the king, right?
Ah, yes, the king's story. This one's a classic. So the king wants to reward his carpenter, Chegu.
Nice. What's he getting? A raise.
Even better, land. But instead of giving him a fixed plot,
Uh-oh, here comes the catch.
the king says Chegu can have as much land as he can enclose with 100 meters of wire.
Okay, so on the surface, that sounds like a sweet deal. But I'm sensing there's more to it.
Right, now it becomes a puzzle.
Mm-hmm.
How do you maximize the area inside that fixed perimeter?
Because you could make a long, skinny rectangle or...
Or you could try to get more space with a different shape. It's not just how much wire you have, it's how you use it.
Talk about a brain teaser. So what does Chegu do? Does he just start laying down wire randomly?
No, he's smarter than that. He starts by making different rectangles, experimenting, see how the length and width affect the area inside.
Trying to find that sweet spot, get the most bang for his 100 meters.
Exactly. But here's where it gets really interesting. Chegu's wife steps in. She says, why don't you make a circle?
A circle. Now she's thinking. But would that really give him more land?
It would. Circles, they're kind of the superstars when it comes to maximizing area. You give a circle a set perimeter, it'll enclose more space than any other shape.
So Chegu should have ditched those rectangles and gone full circle from the start.
Exactly. There's a reason we see circles everywhere in nature and design. They're just incredibly efficient.
But why are circles so special in that way? What's the underlying principle there?
Well, think of it this way. With a circle, every point on the edge is the same distance from the center. No corners, no wasted space. It's the most compact way to enclose an area. Think about soap bubbles. They naturally form spheres.
Right, because that shape holds the most air inside.
Exactly. It's the same principle. But let's move on to another interesting thing from the book, the Pass Through a Postcard Challenge. Have you heard of this one?
Oh, yeah, that's a classic. It's like you have a regular postcard.
And you have to figure out how to make one cut, just one cut that lets you step through it.
It sounds impossible at first, like you'd need a way bigger piece of paper, right?
Exactly. But there is a solution, and it really shows how our intuition about area and perimeter, it can be tricked.
So how does it work? Don't leave me hanging.
You have to think beyond the normal boundaries we put on shapes. Think about how to manipulate the material itself.
So you're almost tricking the geometry to find hidden possibilities within the same area.
Exactly. That's what makes this puzzle so clever. It forces you to question your assumptions and get creative.
We started with kids comparing dried mango slices, and we ended up talking about the geometry of circles, population density, mind-bending puzzles. Who knew area and perimeter could be so fascinating?
It just shows that even in those seemingly basic concepts, there's always more to uncover.
It reminds you that learning and curiosity, they have no age limit.
Absolutely.
So next time you're dividing up a pizza, rearranging your furniture, even just admiring a building, take a moment to think about the power of area and perimeter. They're shaping our world in more ways than we realize. Until next time, keep exploring.